Alright, let's look at the homework 9.1, problem number 2. Alright, let's look at part A. So we want to find the k value such that this y equals cosine of kt satisfy the given differential equation. Alright, so let's look at that. Alright, so first thing I would need to do is find the second derivative. So first derivative, so y prime is equal to, alright, so derivative cosine is negative sine. So you have negative sine of kt, but because of the chain rule, you have to multiply by k. So you have a negative k sine of kt. Then we take another derivative, y double prime is equal to, right, negative k is already there, but the derivative sign is cosine of kt, right, and times k, so we put square there, right, so we have that. Alright, so let's plug these guys into the differential equation so that we can solve for k. So 9 times, so we're going to have a 9 times, alright, y double prime, so it's going to be a negative k squared cosine of kt, right? This is equal to, right? So negative 64 times y is cosine of kt. Alright, so we can divide through by cosine of kt, so we can cancel that because that's in common in both sides. And also we can divide it through by say negative 9. So I'm gonna divide through by negative 9 here and a negative 9 here. Alright, then you're gonna have, let's see, so you can cancel negative 9, negative 9. Alright, then also negative sign cancel out. Alright, then we can take the square root of both sides. So if you take the square root of both sides, we get the k value is equal to plus or minus, right, square root of 64 is 8, and then square root of 9 is 3. So it's a plus or minus 8/3. Right, so let's plug it in. Right, so we get negative 8/3, comma, positive 8/3. Right, so let's check the answer. Alright, submit for testing. Alright, then let's look at part, so we got part A correctly, so let's look at part B. Alright, for those values of k, so which means that the k is either negative 8/3 or positive 8/3, verify that every member of the family of the function y equals a sine of kt plus b cosine of kt is actually also a solution, right? So conveniently, they actually took the derivative for us. So we have all three derivatives given here. All right. So the given differential equation 9y double prime is equal to negative 64y is equivalent to. All right. So look at all they did was move this term over to the left hand side. So the right hand side is going to be 0. Right, because everything is over to the left hand side. All right, thus left hand side, which is this guy, right, they just plug in y double prime here and 64y, so y is just a sine of kt, so kt, and plus b cosine of kt. Right, so we have that. Then distribute 9 to each term, so we get that, and distribute 64 to each term, so you have a 64 a sine of kt. Right, then you have a 64 distributed the second term, we get that. Alright, then what they do was collect the term with sign in it. So then you have a 64 goes here, and negative 9a, negative 9k squared there, so a sine of a kt. If you collect the cosine term, you have a 64 there, and then minus, all right, and the 9k squared, and then we have to have a b there, so I'm gonna put the b there here, and the b, all right, is going to be the second term. So just collecting the terms with the cosine of kt in there. All right, so this is going to be actually equal to 0 because since k squared is going to be 64 over 9. So you can see that if you plug in 64 over 9 here, and the second term is going to be 0. And if you plug in 64 over 9 here, again, that's going to be 0 too. So we get 0. All right, so let's check the answer. All right, submit for testing. All right, it came back and looks like we got everything correctly. Oh, actually, there's one thing I messed up. All right, what did I mess up? Oh, actually, I didn't put A there. All right, so let's check again. Sorry about that. All right, oh, actually, the sign of kt is actually already written, so I didn't need that. So all I needed was 64a. So let's check again, and hopefully they'll like that answer. All right, finally we got that one correctly. All right, that's it. I hope that this was clear.